Hey everyone, this is Unit 11, Lesson 7, Perimeter and Area in the Coordinate Plane. So for the do now, this should be pretty simple. You're going to find the area of the shaded region, which means you're going to find the area of this entire square, and then you're going to subtract out the area of that triangle. Okay, so I just wrote that down. Now the area I'm going to call SR for shaded region is going to be equal to the area of the square, which you can either use length times width, or you can use side squared, which is the one I'm going to use. Then we're going to subtract out the area of a triangle, which is 1/2 base times height. And remember, the base is always perpendicular to the height. So try it out, pause the video, come on back and check your answer. Okay, so you should have found out that each side of this square is 4 units. 1, 2, 3, 4, so 4 times 4 or 4 squared, and 1/2 the base of the triangle is 2 units, and the height of the triangle is also 2 units. So 1/2, 2 times 2, so the area of the shaded region is 14. So for the next one, you're going to do the same process. It's going to be the area of the circle, you got it, and you're going to subtract out the area of the rectangle. Excellent job. Write down the formulas, and I'll come right back. Okay, so once again, area of the SR shaded region, area of a circle is on your formula sheet. It's pi r squared minus the area of a rectangle. I'm going to use length times width. So the area of the shaded region is pi times, now remember the radius is drawn from the center of the circle to any point on the circle. So that's going to be 3 squared minus the length of our rectangle is 2 and the width is 4. So the area of the shaded region is 9 pi minus 2 times 4 is 8. And that is the exact answer. It does not say to round, so you can leave your answer just like that. For example number 1, it says consider a triangular region in the plane with the following vertices. So remember, if you're having a problem graphing, you can always put x and y. X goes under the first coordinate and the y goes under the second coordinate. So you're going to plot all your points. So you go over 5 on the x-axis for A, and then you go up 2, over 3 on the x-axis, then up 4 on the y-axis. It says find the lengths of the sides of triangle OAB. So to find the length of OB, this is a diagonal line. I don't know how to find the length of the diagonal line just by what am I trying to say? Counting boxes. So what I'm going to do is form a right triangle, and then I'm going to count the vertical distance, which is 4, and the horizontal distance, which is 3, and now I can use the Pythagorean theorem. Remember, the C term is always across from the right angle, and I'm going to use the Pythagorean theorem to find the length of OB. So in this case, A is 4 squared plus 3 squared equals C squared. 4 times 4 is 16, plus 3 times 3 is 9. 9 plus 16 is 25. That's equal to C squared. The opposite of squaring is square rooting. So the length of OB is 5. So pause the video, use the Pythagorean theorem. You're going to use the same process to find the length of BA and OA. And then we're going to find the perimeter to the nearest tenth. All right, so I know when I printed mine out, this got cut off. It says state the perimeter, which means to add all sides to the nearest tenth. So that means do put in the square roots. So we need the length of OB, which we found to be 5, the length of BA, which is radical 8, and the length of OA, which is a square root of 29. And when you type that into your calculator, you should get 13.21. So the perimeter is 13.21. We're rounding to the nearest tenth, which is the first number after the decimal place. So our final answer, since the next number after the 2 is less than 5, our answer is 13.2 units. Excellent job. Example number 2 says calculate the perimeter. Again, that means to add all sides of the polygon. So the perimeter means to add the length of BC. Now that's a straight length, so I'm just going to count. 1, 2, 3, 4, 5, 6. That's 7 units for BC. The length of AB is 1, 2, 3 units. But the problem with AC is that it's a diagonal, and I can't count boxes. So we're going to do what we did on the other page. We're going to form a right triangle. And then we're going to do the Pythagorean theorem. 1, 2, 3, 4, 5, 6, 7 units. 1, 2, 3, 4. So to find the length of AC, we're going to do the Pythagorean theorem. And we're going to do 7 squared plus 4 squared equals C squared. 7 squared is 49. Is that 4 or 3? Let me just see. All right, sorry about that. The distance from the right angle up to point C is 3 units. So 49 plus 9 is going to be 58. And the opposite of squaring is square rooting. So the square root of 58 is the length of AC. And And it doesn't say to round, so I can just add like terms, which is 7 plus 3, and I can leave this as 10 plus the square root of 58. If you'd like to put it in your calculator and round to the nearest whatever decimal, just make sure that you're rounding correctly. All right, next question says calculate the area. Well, this is a triangle. The area of a triangle is 1/2 base times height. And remember, the base and the height are going to be the perpendicular distances. So it's 1/2, the base is 7, and the height is 3. And when you plug that into your calculator, you're going to get 10.5. And again, anytime I'm going a little bit too fast because I don't want to make the video too long, always pause the video. Try it out and then come back and check your answer. And here we go. The center, example 3, the center of circle Q has coordinates of 3, -2. Now, circles are named by their centers. So that's how I know that this point, +3, -2, notice how I labeled it XY, that's going to be Q. And this circle passes through the point 7, 1. So if this is the center, remember, circles are going to go around that center, okay? So it says determine and state the length of the diameter. Remember, the radius is going to be half. Remember, 2 radii in opposite directions make up the diameter. So if we can find the length of this radius, then we can double it and find the length of the diameter. So once again, this is a diagonal line, so I cannot count boxes, but I can, you guessed it, form a right triangle and use the Pythagorean theorem. So why don't you guys try that out and meet me back here? So I got the length of A to be 4, so 4 squared is 16. I got the B to be 3, so 3 squared is 9. 16 plus 9 is 25. The opposite of squaring is square rooting. So the length of QR is 5, which is the radius. And we already know that we discussed before, the diameter is 2 times the radius, so 2 times 5 is 10. Now it says state the area of the circle to the nearest tenth. So you should know that this formula is area of a circle is pi r squared. That's also on your formula sheet, so always keep that handy. The length of the radius we just found to be 5. So we're going to put in pi times 5 squared, and it does say put pi in. It says round to the nearest tenth, unlike the do now where it said leave your answer in terms of pi. So you can see here, when we put in pi times 5 squared, we get 78.53. We're rounding to the nearest tenth, so we're rounding to the number after the 5. So since the next number is less than 5, we're going to leave that 5 alone, 78.5. Now it says find the determine and state the circumference. Well, that's also on your formula sheet. The circumference of a circle is pi times the diameter. Well, in the first part, we found the diameter to be 10. So now we're going to do pi times 10, and once again, they want us to round to the nearest tenth. So once again, you can see when I put this into the calculator, pi times 10 is 31.41, and we're rounding to the nearest tenth, which is the first decimal place. Since the number after the 4 is less than 5, we're going to leave our answer as 31.4. You're doing a great job. Example number 4, given rectangle ABCD as shown. Determine and state the perimeter. Remember, perimeter means to add all sides of the rectangle. Now, what do we know about a rectangle? Opposite sides are congruent. So I highlighted, I said the perimeter is equal to side AB plus BC plus DC plus AD. Now, notice here, AB and DC are opposite sides. I really just need to find the length of one of those by, again, using the Pythagorean theorem. So A is going to be 2, and B is going to be 2, and whatever length AB is, so is DC. And then I'm going to find the length of BC, and I know that the length of BC is going to be the same length as AD. So we're going to, once again, use the Pythagorean theorem. Go ahead, pause the video. By now, you guys all know how to do this. And come back, and let's check our answers. So I found the length of AB to be the square root of 8, which means the length of DC is also the square root of 8. I found the length of BC to be the square root of 18, which means the opposite side is also the square root of 18. And then I'm just going to combine like terms. So there's really a 1 in front of all of these square roots. So 1 radical 8 plus 1 radical 8 is 2 times the square root of 8. And radical 18 plus radical 18 is, once again, there's really a 1 in front of that. So that's plus 2 radical 18. It doesn't say to round, so you can leave your answer in exact form. So 2 square root of 8 plus 2 square root of 18. Once again, it doesn't specify. So if you do round, just make sure that you're rounding appropriately. Now it says determine and state the area of the rectangle. Well, the area of a rectangle is the length, which in this case, square root of 8, times the square root of 18. And once again, it does not say to round, but when I do the square root of 8 times the square root of 18, I actually get the square root of 144, which is actually 12. And I just wanted to show you guys on the calculator so you can check your answer as well. All right, try the next one, pause the video, and I will meet you back with your coordinates plotted. All right, so if you don't have graph paper, just do the best you can. Just draw your axes, X and Y, and then just estimate it. It's good enough for now, okay? So it says that prove that ABCD is a parallelogram. So what do we know about a parallelogram? Well, hence the name parallelogram. It means that opposite sides are parallel. But we also know opposite sides are congruent. There's a bunch of different ways you can do this. If you want to prove the opposite sides are parallel, you're going to prove that the slopes are congruent. So remember the slope, we're going to find the slope of AD, D is in dog. And remember the slope is the change in Y over change in X. So from D, I go 1, 2, up 3 units. So that's the rise. And I go over 1 unit in the negative direction. So 3 over -1. Now I'm going to check to see if the opposite side also has the same slope. Remember, slope is the change in Y over change in X. So I start with the bottom point. I'm going up 1, 2, up 3, and to the left 1. So up 3, -1. These two line segments have the same slope, therefore they are parallel. We're also going to prove that the other opposite sides are also parallel. So why don't you guys pause the video, come on back, and let's see if we all have the same answer. So from point B, did you go up 4 and -6? 4 over -6. We're going to reduce that, okay, to compare slopes in the simplest form. So the number 2 goes into 4 2 times. The number 2 goes into -6 3 times. Now we're going to check the slope of line segment DC, which is again the change in Y over change in X. So from C, I'm going to go up 1, 2, 3. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6. So +4, -6. Once again, when you reduce that, you end up with the same exact slope. So now you're just going to make a statement about that. So that was really easy and straight to the point. Just make a statement. ABCD is a parallelogram. Okay, it says prove. So in a statement, you're going to show your work and then make the statement. Both pairs of opposite sides are parallel. Showing here, okay, they have the same slope, meaning side AD is parallel to side BC, and side AB is parallel to side DC. Okay, now then you're done. You could have just been done. It's nice and easy, straight and simple. If you wanted to prove that the opposite sides are congruent, I actually did this earlier, okay, you could have found the length of each side, and you would have stated and shown that side AB with a length of the square root of 52 is congruent to the length of DC with the square root of 52 length, and also that this square root of length AD is a square root of 10, and BC also is a square root of 10. So then your statement, if you wanted to do it this way, would have been ABCD is a parallelogram because both pairs of opposite sides are congruent. So either way is fine. You don't have to do it both ways. I'm just giving you options. You guys are doing such a great job. And here's the independent practice. So once again, if you don't have the sheet, just copy this down on a separate sheet of paper. With the graph, just sketch it. Just do an X and Y axes. You don't have to draw every single point. Just do what you can. And don't forget to take pictures or scan your completed packets. And don't forget to submit it up into Canvas. Hope you're all doing well. Have a wonderful day. Keep up the great work.